Hi guys, in this video we will discuss a tabular integrals. For example, I'm interested in computing let's say e to the negative x times, let's say, x cubed dx. Okay, how do I compute this integral? So first of all, I'm going to use tabular integral integration. It's called differentiate and integrate. So differentiate part would be polynomial part, and integrate part is the rest of it, e to the negative x then. So let's differentiate x cubed. You get 3x squared, differentiate one more time 6x, and differentiate one more time 6, and then differentiate one more time 0. If you integrated negative e to the negative x, e to the negative x, negative e to the negative x, and then e to the negative x. So the next step is to cross multiply with the plus sign first, and then with minus sign, and then plus sign, and then minus sign, and then finally, if you want to stop at this point, you just multiply these two and integrate it. But if you multiply and integrate the last step, you get 0, right? And then with the plus sign, of course, now minus plus, and so on. Okay, so this integral now is equal to e to the negative x times x cubed dx is now equal to negative x cubed times e to the negative x. So let's keep e to the negative x outside in here. And then, of course, there will be a plus, a constant in that. And then 3x squared, and then with minus sign, so negative 3x squared times e to the negative x. So I have this e to the negative x in here. 6x times negative e to the negative x is negative 6x. And then 6 times this is negative 6. And then 0 times e to the negative x is 0, so there is nothing coming from here. So the integral is, like, let's rewrite it, e to the negative x times x cubed dx is negative x cubed plus 3x squared plus 6x plus 6, and then e to the negative x plus a constant. You can write it that way. So what I notice in here is that if you start with any number, let's say 3 in here, you get 6 in here, which is 3 factorial. You keep multiplying the previous number, right? So you can think of this actually as like this 6 is 3 factorial, and then you have 3 in here. So what if I do that for any integer number? So, like, what is the integral of e to the negative x times x to the, let's say, k times dx, and then k is just an integer number in here. And I'll do the same thing. Let's do it. Differentiate and integrate. And then if you keep differentiating x to the k and integrating e to the negative x, the first term is k times in here x to the k minus 1, and then k times k minus 1 x to the k minus 2, and then differentiate one more time, k times k minus 1 times k minus 2 times x to the k minus 3, and so on. You will get in the end k factorial times, and then as you see in here, when you have 3 terms, like in here k terms, you just subtract like k minus 2 and then this, so you get x to the 0 in the end. And then you integrate this negative e to the negative x, e to the negative x, negative e to the negative x, and then you keep writing. And then in the end, either you get this plus or minus. Let's see which one we are going to get. So this is a constant, the next term is 0 in here, and then something either plus or minus e to the negative x. So plus minus, minus plus. So which sign do you think we get in here? So do the cross multiplication with the plus sign and then minus sign, right? And then this 2 with the plus sign and then minus sign. And then as you see, if you keep multiplying with the plus and minus sign like this, you get negative times x squared, negative times. So each term in here will be, so in the end it will be negative. So the final term will be negative 2. So probably this term is going to be then, if it is plus, so this will be, so let's say if this is plus, that will be minus. So if this is minus, that will be plus. Eventually the opposite signs will take place here. So overall, if we summarize what we discussed, so e to the negative x times x to the k dx is equal to now. So there's each of them like will yield negative sign. Let's put this negative sign. You get x to the k times, in the end you will get e to the negative x plus a constant. So plus k times x to the k minus 1, and then plus k times k minus 1 times x to the k minus 2, and then you keep writing this until you get k factorial in the end. Alright, so you can see that, for example, if I integrate this from 0 to infinity, e to the negative x times x to the k dx as an example. So you just improper integral in here. So if you pass to, so infinity in here as a limit, like treat this as a like t goes to infinity from 0 to t, e to the negative x times x to the k times dx. Then if you just plug t and 0 and then pass to infinity, pass to limit, what do you get? If you plug t and then 0, x equals 0, this will be all there. So limit t goes to infinity, you get, there is negative sign, t to the k, right? And then plus k times t to the k minus 1, and all the way down to k factorial times e to the negative t, and then minus, when you plug 0 in here, this term is 0, this term is 0, this term is 0, and the only thing that's left over is k factorial times e to the negative 0. So you get k factorial actually left. But when t goes to infinity, because of this exponent in here, negative t exponent, these will all go to 0. So we had one correction in here. So we forgot negative. When we plug it, we get negative in here. So negative is plus, so you get k factorial. So what we have shown so far is the integral from 0 to infinity, e to the negative x times x to the k dx is equal to k factorial when k is an integer. I hope this helps. So this is, by the way, gamma function, and this is called gamma function at k plus 1. As far as I remember, this is gamma of k plus 1. Thank you for listening, and see you in the next video.